Hello all and welcome back. So in this video, let us move forward and now let's try to find the length of our linked list. Length of linked list. Now again, the understanding is same. We will be just given the head, right? So we have this particular sample as a test. It is having 5 nodes. What I should do, I should define a function. So let's say def length and it should just get my head and it should return me what the length is, right? So it should return, let's say length. Okay. So now let's talk about what the logic will be. I feel the logic can be very much same to the one where we printed our linked list. That is, we started from the head and we are moving to each node until our temporary variable becomes none. Because when it is becoming none, that implies that nothing is there after, right? So when it was finally equal to none, there was nothing after that particular node. And if I just maintain a count variable as well along with that and keep on adding 1 to my count, I should be able to get my length, right? So the overall idea is pretty simple. We are just going to move to each and every node until we reach to the last node and have my temp variable as none. Great. So let us try to code this everyone then. Let's say, yeah, def length. Okay. And length of linked list. Let me make it like this. And I will be getting a head. Now, as a good habit, of course, we should make temp variable. Okay. And one answer as well. So let's say answer is 0 initially. Now, while, okay, so as of now, I've just defined temp and head, temp and answer. While my temp is not equals none, right? What I should do, I should just move temp to the next one. Okay, so again, this is something which we have already seen. Temp initially is head. So let me just write temp as well. Temp initially is head. Temp dot next, it's going to move here. Then it's going to move here. Then it's going to move here. Finally, it will become equal to this, right? Once it becomes equal to this, then I think we should stop and when it become equal to none and return the answer. So now let us code the same. When we are moving, we also have to make sure that answer we are adding by 1. Okay, so this is just shorthand rule. Let me maybe write it like this only, should be fine. Okay, if we do this, then let me just return the answer in the end. And I think we should be good, right? Great. So to test the code, of course, we will have to create a linked list. Just one thing, what I'm going to do is I'm going to copy all these things. So all these functions which we have made into a new file, which we can say commons. The reason for that is instead of copying them every time, I hope all of you are aware of this particular way. So I can make a commons.py file. In this file, I'm just pasting all these functions, right? The reason for that is I want to use them, right? Instead of copying them again and again in the same, this particular folder in each and every file, what I can do, let me just directly import them. So again, from commons, common import node and get take input better and let's say println as well. Okay, so this is a common way we do that, everyone. We are just keeping all the functions and the classes structure, everything into a file from where I can import that, right? So instead of copying them every time, I will just paste any function which I want to use in this particular directory inside this for this file, right? So we have done this already. I am pretty sure you must have seen the same when oops was also taught. So if not, just you can use this particular way to import your functions. Great. Now what I can do, let's say head of ll is equals to take input better. I can just call this. Once I get my head, I can just print, or let me just get length is equals to length of ll. I'm just passing my head of ll, right? Head of linked list. And let me just print the length, right? So this is just going to print whatever the length is. Now let us run this and see how it's going to happen. So yeah. Okay, let me just bring this terminal maybe to this side so it is a little bit nicely visible. Mm, Okay, so let's try this. Should be fine. It is asking us for the value. So let me enter 10 first, then 20, then 30. Okay. And after that, let me enter 40, 50, and -1. Okay. So once I do this, then I have 5 nodes in my list, right? If I now press enter, we are able to get 5 as an answer. Okay. So yeah, pretty sure this should be easily understandable, but let us will still do the dry run of this once in the Python tutor so that we are able to visualize the same as well. Okay. So let me just edit this code and I'm just gonna paste everything here. Okay. Common will not be here. These functions are already present. Great. So yeah, let us run this now. If we move forward now, everyone, again, lots of these function and structure gonna get defined. Okay, head of linked list. It's going to take the input. Okay, this is going to take lots of steps. So let us just quickly run and make the linked list. So I'm just defining the linked list. We have already seen that. Okay. Last 30 and say 40. And in the end, just putting -1, right? So we have seen the steps a lot of time. It is just defining my linked list. Now, once I'm out of this, once I'm out, what I'm going to do, the head is returned. So you can see the head of linked list. This is the whole head. It is having 4 nodes starting from head all the way to tail. Next is none. We just have this head, right? So let me call the length function now. Once I call this length of linked list function, we are creating a temp which is equals to head and answer which is equals to 0. Now temp gonna get created. It's pointing to head. We are just going to move. Okay. And in these questions, always make sure that you are handling the edge cases or the cases, for example, let's say when head is none, right? So we have to see this loop will not run and the answer will be 0. So always make sure that these kind of cases where just 0 nodes are there or a single node is there, these type of cases are handled. Okay. Now let's go and run this. So temp, so see, temp is here as of now. It's going to move to the next one. And I'm going to add 1 to my answer. Okay. Again, the same thing is going to happen. Temp is going to move the next one. And I'm going to add 1 to my answer. Just like this, of course, we can just run it. And finally, when temp is at this particular case, answer 2, let me make it 3. Okay. And as of now, temp has reached to this last node. So just run this. Temp has become none. But before becoming, sorry, after it becomes none, we have to still increase the answer, right? It is inside and after this. So answer is going to get 4. Now we will come out of this loop. Once I come out of this loop, I can just return the answer. Return value 4. Answer, the length is 4. And of course, I can print that. Okay, everyone. So great. I hope you were able to visualize using this thing exactly what is happening. Okay. Now, let's go back to the code and I would like to you all to do one more thing. So now let's also write a function length of linked list, but this time it's recursive. So I don't want to use iteration. I want to use recursion. Okay. So let us go back and see how we can do that as well. Okay, everyone. I'm going to teach you for this particular code, and in future we are going to write code in iteration as well as in recursion. Okay, great. So linked list length using recursion. Okay, so let me just copy this whole list again. I want to explain you what the exact process is. Okay, so process is very important to understand. Great, so let's just copy this. Yeah, cool. So we got our linked list here, everyone. Now exactly what we have to do, pay attention. Again, just let's think of recursion the way we have understood it. There were 3 steps in recursion. First used to be the base case. Second used to be recursive call. something which we used to assume, don't need to question this. Third, our work, right? Now, again, if you think about this, if we are able to just do these three steps, then we can say that recursion is going to work for us because that is how we have understood recursion, right? Now, let's think about each one by one. First is base case. I believe that base case can be equals to when head is none. I can just return 0, right? When my head is none, I can say that it's a base case because it's an empty list, right? What are you going to find out in the empty list? The length is going to be 0. Great. Now let's see on the recursive call. So if you remember, I told you in the starting that how my linked list is a linear data structure, just like an array or list, right? So we have seen how we used to do recursion on arrays or list. We used to divide them, right? Either by indexes or in half, or just we used to keep the first element or the last element. So the understanding is exactly the same here. Now what I'm gonna do, pay attention everyone, what I'm gonna do is I'm gonna just ask recursion to find answer for this right part. Because if we think on this, this is also a separate linked list, right? So I am just reducing the problem. I am just reducing the problem in half. So we can ask recursion, we can ask recursion to get length of head dot next. Just like when we were dividing or breaking our array by working on the first element, the rest over was also an array. Similarly, in this case, this whole leftover list is also a linked list, right? Recursion, or rather, we also don't care if this is being saved somewhere, this reference, right? As of now, we don't care. For the new recursion call, this is going to be the head for my recursion, right? So if recursion is going to get us the answer, if recursion will be able to get the answer, which we know it will, the last work is ours, which is we just have to do 1 plus recursion answer. Okay, so let me write this in that pen so that you are understanding it. Recursion answer, right? So the color coding so that you are able to remember this. Yeah, I think that the whole thing which we have to do. Again, I will repeat it. First is the base case when my head is none. Okay, when the list is empty, I just have to return 0 because that's an empty list with a length of 0. For the recursive call, just like we were dividing our array, here you have to just understand one thing. We can, of course, only work on the head and we can give the rest leftover linked list, right? We can give this leftover linked list, which is again a smaller linked list. That's how we used to do recursion, right? Break our problem, the same problem into smaller problem. So finding length of this list is a smaller problem for me, right? Once I get the answer for this, then I know that I have one node to work on. And for that one node, we can just say 1 plus whatever the answer I'm getting. Okay, so let us just run this everyone. Yeah, so let us code this. If my head equals to none, then I can just return 0. So this we can say is the base case. Okay, great. Then let's move forward. Let's say recursion answer. It's going to be length of my linked list into head dot next. Now recursion is going to get the answer. We don't have to question how exactly answer is going to come, right? And if this is done, I can just say 1 plus whatever answer recursion has got. Okay, cool. So let us just do one thing. Maybe just call this length again, but this time call this function. Okay. So again, of course, you can do the dry run for this particular case. I hope it is a lot clear. What's going to happen is that if we see the run, recursion call is going to get made for this, then call is going to get made for this, then this, then this, and finally call is going to get made for this null because for this particular last tail node, head dot next is null, right? It is going to return the answer. Let me just draw that as well. It is going to return the answer as 0. Okay. We are going to add 1. We are going to add 1 and just say that 1 is the answer. Similarly here, 2 will get returned. Here 3 will get returned. Here we will have 4 which is returning. And finally I can just add 1 and say 1 plus 4. This is my answer. Right, everyone? So I hope the overall idea of how recursion flow will be there is clear. So if that's clear, then just let us code that. Yeah, just we have to check this, right? Great. So again, let me run this. So let us clear this. Yeah. First node 10, second node 20, third node 30, fourth 40, 50, and -1. And we seem to get the same answer from both. Okay, so I hope, yeah, our code is working fabulously well. And I hope you are able to understand the same as well. Now, again, I took some time and help you visualize this because moving forward, many operations we will be doing iteratively as well as recursion, using recursion as well. So we should be aware that how we can use linked list and recursion. Okay, so cool everyone. Now let's meet in the next video where we are going to do some operations on our linked list. Thank you.